Good morning, good afternoon, good evening, good night. I don't know what time it is where you are, but this is Easy as Pie with Mr. Carpenter. I am Mr. Carpenter, and today is the day for the dreaded system of three equations with three variables. And as a prereq, I should say, your elimination skills should really be at the top of their class. If they are not, then I would recommend checking out my elimination video and getting solid with that strategy, right? Because that is going to be our primary tool here. And the whole point of solving a system of three equations is that we know how to solve a system of two equations, right? And a big strategy for mathematicians is to turn something that they don't know into something that they do know. So we're going to see what we can do to turn this system of three equations into a system of two equations. Now I'm going to take a moment and I'm going to label these equations 1, 2, and 3. And I want you to look at them for a moment. Which two equations could I add together and have one of the variables cancel out immediately? If you said equations 1 and 2, you are correct, right? Because these will cancel out. My apologies. I am going to get this video in one take. If you said 1 and 2, you're correct, because this is going to cancel out my y variables, right? You'll notice that the coefficients are positive 2 and negative 2. So if I add those together, 2y minus 2y will be 0. So that's what I'm going to do. I'm going to add equation 1 and equation 2 together. So that would be x plus 2y minus z equals 7. And notice when I write my z, I put that little tail in the middle, so that way I don't confuse it for the number 2. It sounds stupid, but believe me, it happens way more often than you might think. We're going to add these together. X plus x is 2x. 2y minus 2y will cancel out. And 3z minus z, or negative z plus 3z, is positive 2z. And that is equal to 8. And now I'm going to hold this equation off to the side, right? Because I need a system of two equations in order to do anything substantial. So in this example, I added equations 1 and 2. What I need to do is I need to find a different pair of equations and try to cancel out the same variable. So I need to cancel out the y variables again. So I'm going to pick equations 2 and equations 3. And you're going to see why in a moment. So equation 2, x minus 2y plus 3z equals 1. Equation 3, 3x plus 4y plus 5z equals 12. Now at this moment, if I add them together, my y variables will not cancel out, right? And I'll be worse off than I started. So just like in regular elimination, what can I multiply one of the equations by in order to get y variables that will cancel out, right? In this case, it would be really nice if this was a negative 4, because negative 4 plus 4 would be 0. Well, I can get there. I just have to multiply by 2, right? Because 2 times negative 2 would be negative 4. I distribute to everything. Let me rewrite this one more time. 3x plus 4y plus 5z is 12. And when I distribute, 2 times x is 2x. 2 times negative 2y is negative 4y. 2 times 3z is positive 6z. And 2 times 1 is 2. And now I have that perfect pair of opposites that I'm looking for, right? Negative 4 and positive 4. They're going to add up to 0, which means they'll cancel out. 2 plus 3 is 5x. Y's go away. 6z plus 5z is 11z. And 2 plus 12 is 14. Great. And now, remember our goal at the beginning, right? I wanted to turn this into a system of two equations. And I did, right? I have a brand new system now. I'm going to shuffle this up to the top. And here I have, in black, 2x plus 2z equals 8, and 5x plus 11z equals 14. And now I get to solve this system by any means possible, right? We already have our two primary methods for solving our systems. We can use substitution or we can use elimination, right? In this case, I believe elimination is the primary strategy, although it is going to be a bit of a headache either way, because none of my variables look like they're going to cancel out immediately, right? Actually, they're all positive, so there's definitely no way they're going to cancel out. Not only that, but I can't multiply one of the equations by an integer and get it to be an opposite of the other, right? 2 times anything that's an integer is not going to get me to -5. So now I got to think about a least common multiple, right? 2x and 5x. Well, I could turn 2 into a positive 10, and I could turn 5 into a negative 10, right? And once I do that,
do you want me to come back?
no, I'm doing this in one take, so you're part of the video now.
Oh, okay. Well, I'm bringing you your stuff for.
Thank you.
I'll just need it next week.
Yep. Like I said, we're doing this in one take, not re-recording. So anyways, looking at that 2x and that 5x, right? They both multiply out to 10, right? Because 2 times 5 is 10 and 5 times 2 is 10. So I could turn them into a positive 10 and a negative 10, right? That's different than something like if I had x and 4x, right? I could only have to multiply one of the equations to get those opposites. In this case, I can't do that. I have to multiply both. So I could multiply this 2 by a positive 5, and I could multiply that 5 by a negative 2, right? And that will give me the pair of opposites that I'm always looking for, that positive 4 and that negative 4, that positive 2 and that negative 2. In this case, it's going to be that positive 10 and that negative 10. We do our distributing. 5 times 2x is 10x. 5 times 2z is 10z. 5 times 8 is 40. Negative 2 times 5x is negative 10x. Negative 2 times 11z is minus 22z. And negative 2 times 14 is negative 28. Now that I have this pair of opposites, we get to add. 10x minus 10x will go away. 10z minus 22z is negative 12z. And 40 minus 28 is positive 12. And now we're down to one variable, right? Just got to divide by negative 12. And z is negative 1. And once you find out the first variable, the rest of it is pretty smooth sailing, right? I can pick any equation I want from these two, plug z in and solve for the x. And then I can take x and y and plug it back into one of these and solve it for y. So let's just pick this one because it looks like it's easier. 2x plus 2 times z, which is negative 1, equals 8. So 2x minus 2 is 8. Add 2 to both sides, 2x is 10. Divide both sides by 2, x is 5. Okay? And now, both of these go up to one of those equations, right? Because I have 2 of the 3 variables, so I can solve for the third one that's missing. X, which is 5, plus 2y, minus z, which is negative 1. That double negative will throw off a problem that you've been doing such good work on the whole time, and then you do minus 1, right? When it's really minus negative 1. Okay? Minus negative 1 equals 7. All right, let's combine like terms here. So 5 plus 1, right, because minus negative 1 is the same as adding 1. So we got 2y plus 6 equals 7. Subtract 6 from both sides. 2y equals 1. Divide both sides by 2. Y is 1/2. Now, if you were looking at this problem, you're going, wow, that's a lot of work. That's because it is. Right? This problem requires a lot of work. That's why it's going to show up at the back end of your region. That's why there's only going to be one of them on your test, right? Because it's a lot of work. But the work itself isn't that bad. It's just time consuming and there's a lot of room for mistakes. And when there's a lot of room for mistakes, students tend to psych themselves out. But once again, like I said at the very beginning, if your elimination skills are on par and your basic algebra solving skills are on par, you are capable of all the work here. It's just a matter of structuring it in a way that it's easy, bite-sized chunks, and that you're able to take care of all of it in one smooth process. All right? But with that in mind, thank you for watching, and let me know if you have any questions.